All right, so welcome back, everyone. I've I've changed some of the settings on my mic so that hopefully we can get a little bit less reverb out of this relatively large living room. But anyways, I promised you that at some point I would cover the discussion, questions and prompts that we've used throughout the semester so far, and better late than never. Here it goes. But before we get started, this is the first time I'm saying something like this, but um, we've gathered a pretty decent following on YouTube. There's quite a few views on the channel. We get about 25% of the viewership, 25 to 30% of the viewership are students. So that means 75%, roughly three quarters of the people viewing this video right now are not my students. So if you enjoy watching this, if you like what you're seeing on the channel, please like and subscribe, and feel free to like, comment on the videos, reach out to me, anything like that. Especially if you are interested in a career in mining engineering, particularly if you want that, career to be in, sort of engineering technology. This Bluefield State University is the only program in the country. If you are outside of the country, then there are others, but in the U.S., this is the only one. If you want to go to another one, the next closest is Ontario, so Canada. But anywho, that's my shameless plug for the YouTube channel. And let's get into some of the discussion questions for our MIET 392 underground mining class that we've covered so far. The first one was just for bonus points, introductions. I think everybody introduced themselves. And yeah, if you look at those, you can see that we have a decent, bit of diversity in our group, and I think that is apparent if you're from my viewpoint, where or if you went back and looked at like all the discussion questions, I think you can see who's got background and experience in surface mining, or who's got background, more background and experience in underground mining, whether or not that's in longwall or rim and pillar. You can kind of tell because that's sort of the first thing that comes to our mind is what we're familiar with, right? And so yeah, that was a good idea to have a short intro for everyone out there. But let's get started. We'll just jump right into it. Week two, the question or prompt that was asked said, last week we covered a high level overview of underground mining methods. You saw that each method has advantages, limitations depending on the situation. My father was pretty famous for always telling me that for every advantage there's a disadvantage, right? For every decision you have to make, and it's pretty true, right? You know, and so in your post, identify three key factors that should be considered in selecting a mining method and explain why they matter in practice. After posting, reply to at least one peer, or from me. But it turns out I didn't have a lot of time to get back in there and start posting. But anyways, uh, so kind of my viewpoints on this, and a vast majority of everyone really kind of hit this on the head that you know when you're first, you're going to consider pretty much like what the commodity is, right? Is this coal, or is this metal, or is it non-metal? You know, because that's going to kind of dictate the methods that you're going to use. You know, you need to blast it, or you're going to cut it out to continuous miner, that sort of thing. And the next would be the geometry of the reserve, right? Um, Really, really important. Is it a steeply dipping thin vein of gold? Or is it, a vast territory of coal that you can put a long wall in? Or is it a little bit of coal that's worth quite a bit of money that don't have, the area, or want to put up the capital expenditure for expensive longwall equipment, and you can go in and room a pillar. Uh, so everyone pretty much said that, I believe, because that is kind of two of the biggest things. And then a third would be when you're considering the method. Uh, could be a number of things. It could be um, the actual geology that you're mining in, um, uh, or the depth, right? Just how deep is this reserve? Um, do you need to maybe run narrower panels or something like that, or do something that's different or outside the box, right? Than normal. Other factors can be, if you have, let's say you have, a trona mine or an evaporite mine of some kind. Um, then you have to consider, do you want to do solution mining, right, or something like that, something that's completely different. But generally speaking, I thought everyone, did a pretty good job of answering these questions and discussing, their rationale um, for what they were picking. So if you do think your grade was a little bit low on one of these or more of these discussion posts, that keep in mind that, and maybe I should have been more upfront with this from the beginning, that I like short and to the point answers, just like anyone. But make sure to share enough that you kind of paint a picture of your rationale and your thought process and why you are saying what you're saying, because that's really what I'm looking for, right? Um, the rationale and the thought process. Um, Week three, so we kind of more thoroughly introduced longwall mining and remote pillar mining that week. And the sort of question was, what piece of equipment, continuous miner with boulder, shuttle car, etc., do you think is most critical to the success of room and pillar mining and why? And then from the longwall safety video, which hazards stood out to you the most, and how can miners reduce that risk? Um, Piece of equipment. So obviously, this is a very subjective question, right? That was the whole point of it. So pretty much, if you named anything, I gave you credit for, at least the attempt, right? And then I looked into to sort of what your thought process was on it and that sort of thing. There were several people that chose the modern correct answer, I'll say. Um, Given everything's the same on the section, you can only mine as fast as you can bolt. And so several people picked the roof bolter. Obviously, our classmate that is probably pin and top right now, was very vehemently in support of the roof bolting machine as being the most critical piece of equipment on the section. So hey, I don't blame anybody for picking what they currently run in this case. Uh, you know, and then like I said, that's like the modern standard answer. But in reality, if if we were hand loading the coal, you wouldn't have to bolt very fast to keep up. So I pretty much can see anyone else's sort of argument for other pieces of equipment, including the feeder breaker. I mean, the whole argument on that was that if it's down, then you can't do anything, and well, that's accurate, right? So um, the only thing you can do is catch up on bolting when you're behind. So another shout out to the bolt machine. Um, but anyways, yes, pretty much I accepted just about anything on that, and then was grading based on your reasoning. In the long wall safety video, that most people picked pinch points and hoses. Yeah, they still exist. They do, um, and you still need to watch out for them, of course, as much as you can. But with modern technology, things have gotten a lot safer. We're not manually moving these shields around unless we have to. Something's going on. That process has become automated and has really kind of helped out, particularly down there at the Ram, in the T-bar location. That's was a common uh, source of injuries, right? And we do develop better materials and stuff over time. Guarantee you, if you look at uh, accidents with blown long wall hoses, they have gone down over time, but they still do exist, right? It's not something that's gone away. We've just gotten better at mitigating the hazard, right? Or you know doing a better design to start with. So that's a really good one there. Of course, any of the hazards such as roof and rib hazards, right, can still exist. That didn't that doesn't change over time. That is still there. So that's kind of my thoughts on week threes. So maybe this is week five, I think. I know we didn't do one for week four because of the Cole show, um, but week five. Based on what we learned about shield design, caving height, and periodic wetting, what do you think the overall conditions would be if we mined an upper seam over this long wall panel? Keep it simple, explain in your own words. You mentioned things like roof, rib, condition, floor behavior, where it might be better or worse, and one thing you'd watch for during mining. Yeah, so that was a pretty good one, right? It basically gave, this kind of conceptual question, because I know that most of you are not necessarily familiar with multiple seam mining and the interactions because of it, but I do know that several of you are familiar with longwall mining. And so the idea was like basically, can you describe for me what you think, might be happening above your head, right? Based on these, conceptual block models and stuff that we looked at for the shield design, and think about what it might be like up there, right? And because I have been there, that I can tell you that, yeah, if you were to mine over top of that panel, you should expect damage to the roof, right? Because active subsidence is taking place. Unless you're really far away from there, you're going to see potentially open fractures. They could be closed too. It could be either. Sometimes they close back. Sometimes they remain open. I've seen fractures in the roof where we had very strong, thick sandstone that were 5, 6 feet wide. Okay, open fractures into the top. Um, if you have shale or laminated rock, it's harder to see that, right? You get smaller fractures, and you don't necessarily get those huge open fractures like you do in the sandstone. But you are going to have damage to the top, and you are going to have to deal with it if you're going to try. Some of the our classmates, some of them took this from a long wall perspective. Some of them took it from a room pillar perspective. Either is okay. Um, from the room and pillar perspective, typically, you would advance your panel, within the boundaries of that gob area so that you can take advantage of the de-stressing effect from the gob and do it that way. But so, what would the overall conditions be there? Vertical stress, it's going to be decreased, right? Until that panel width becomes critical, equal to the overburden depth, in which case at the center I would expect, the in situ stress loading. But, beyond that, you're going to see a de-stressor. Okay, so, if you're going to see less vertical stress. You could see an increase in horizontal stress, particularly at the edges of the panel. And that's because multiple seam mining does induce additional horizontal stresses into the mix. Um, so you might see that. In areas where you cross the gob solid boundary, some people mention this, you're going to see ribs falling. That's true. Um, you're going to see indications that the pillars are more highly loaded, right? You're going to see ribs falling. You're going to probably need, rib support, if you're mining any decent height whatsoever. So that's some of the uh, conditions you might expect. If we were mining a long wall over top of this, which has been done, I need to be sure I post that paper as well. Uh, but it was done in Boone County quite a lot. Uh, Generally speaking, what you would try to do is offset the gate rows right so that they're in the de-stressed area, and then you would have your panel over top or underneath of, in this case, over top of uh, the not just mostly gob, but the gate roads will be in there as well. So you want those overlying or underlying gate roads to be within the boundaries of your panel. That way you can support the top the best, and just by using the shields, right? Um, and that way your actual gate roads have then been de-stressed, um, again because of the gob. So that pretty much I think explains what I was going for there about the conditions. Yeah, you do have damage to the floor as well. But I know at least one person mentioned that that's probably easier to control. And generally speaking, it is, right? It's always easier to do that. Uh, if you get some floor heave, it gets too much. Yeah, if you need to, you can come back and grade that out. That sort of thing. Much easier to contain. Also, if you're having water problems, you'll have to deal with it somewhere down the line before it's discharged. But with cracks in the floor, it'll go down to that lower mine, right? And you'll have to deal with it down there. But you know, you sort of eliminate some of your water problems if you have. So sometimes it can get better, right? In a manner of speaking. Okay, I think that was pretty good. Week 6 was a good one, and I think everyone did pretty well in this too. And the prompt was over the past several decades, for at least up until it was last looked at by me, long gateway support practice, they advanced it considerably, right? There's widespread use of cans and tailgates, cable bolts and trusses in the head gates, and design guidelines, aspect ratios, and all that stuff. And how to construct cribs. That you need that. You know, overhang of the crib blocks to make sure the cribs stay stable. We've come a long ways, right? The task was to propose one reason why roof fall improvements leveled off, and to suggest two changes. Once again, there's that. For every advantage, there's a disadvantage. So for the two changes, are there pros and discuss major pros and cons. And so this is actually a pretty long sort of topic. Like I said, I think everyone did pretty well. Most people contributed the reason for the leveling off is that we've basically just kind of met, the limits of what our current, support designs can do, right? And we're kind of at that sort of engineering limit at the moment. That's not bad reasoning. I think that's pretty good. I think the price of coal can work its way in there some, where if you need to start cutting costs, then you'll be maybe switching to different supports and that sort of thing, which may or may not be as good as what you were using. Uh, there's a number of sort of reasons that I think probably together contributed to this, right? That that's what is kind of going on, and that's if you consider the times as well, you know. So I think most people kind of went that route, and yes, that's a really good reason for why that might be. Okay, two changes. A lot of people went with monitoring. That's a really good choice. I think that with more intensive monitoring techniques, we can get a lot better at watching what the roof does, and being able to respond to it if necessary, right? So we will get there. we will get to that point where we're monitoring lots of things. We're already starting to move that way, um, putting in extensometers and stuff like that, especially some of the bigger mines in sort of critical areas. Belt transfers, places that miners are likely to be working, places that are intended to be installed, like long term, right? And a lot of what's pushed by that is pushed behind that is, from insurance agencies, right? But we are going to be moving in that direction. I don't think there's any way around it. To if we're going to get better than what we are today, right? Um, Training. Some people mention training. Training is always a pretty good talking point, right? If you bring up training, uh, and a lot of that goes back to like when you look at injuries, right? A tremendous amount of the roof related and rib related injuries occur during the installation of supports, right? Because they're the guys right there where this newly exposed stuff is at, right? So that's the majority of the accidents. Whether or not additional training from what we have today can make that better, I don't know. But training we've done in the past, such as all of the hands-off stuff that we've done, and then doing some other things like increasing the usage of PPE like Kevlar sleeves and that sort of thing, it's really gone a long way in in changing this, and that's over the kind of the course of my career, right? Whether or not additional training from now, can make that better, I don't know the answer to that. But that's all. Training is always a good talking point, and especially when we're talking about reducing injuries, reducing risk, and that sort of thing. I don't know if so a couple of people did go with support design. I think talking about 9 point cribs, and that is correct. 9 point cribs are extremely strong, right? I mean, they strain hard, which was mentioned, in the discussion post. They strain hard, meaning they get stronger as they get squeezed. Um, I remember working at this one mine. We had a lot of horizontal stress related falls, and so in those you get really long running roof falls. Okay, they'll go forever. They'll go all the way to the solid coal, right? They'll run forever, and I mean we were mining this section, and it started falling, and we got up under it with 9 point cribs and installed those cribs, like I said, all the way out the mouth of the panel, all the way across the mains, all the way to the solid coal. I think it was 3 days nonstop, all shifts, all crew members building cribs, and eventually we got to the point where they got to the point where they'd caught it, right, and kind of stopped it, and then it just went to the next softest entry, the next one right beside it, and started falling again. And but they caught it again. Eventually we got it, but um, yeah, 9 point cribs are extremely strong. They do strain hard. They get stronger as you squeeze them. I've been near not 9 point cribs, but 4 point cribs that were 50% of their original height. They're about, I don't know, probably 7.5 feet or so high, and when I got there, they were just under 4 feet, 4 feet high. They had been squeezed roughly 50% of the height they were installed at, and they were still supporting load, right? One of my father's jobs, whenever he first started, he's kind of early on in his career, he was tasked with cleaning up roof falls. So what he told me he would do is he would go to where the roof fall was, and it'd be sitting on the cribs, right? So he would crawl up under it, set dynamite in all the cribs, come back out, shoot them out, right? So he had to get the top to fall before he could actually clean it up. 'Cause you can't clean it up in that situation. So that's what he would do. Um, and so yeah, so a couple of people did bring that up. It's a good talking point, and there are advantages to wood, particularly hardwood, particularly oak and hickory. Um, there's advantages to it. The biggest reason for the switch to pumpable cribs, was the labor involved, and you both mentioned that as well. The labor involved with the wood. That was one of the biggest switches. Because pumpables are expensive. They're very expensive. But time is the resource that actually costs the most, right? So you need to be able to get them in, and with that you can do it much quicker. Um, what else? Oh, in the West too. Just the ability to get wood is difficult, right? So a lot of times you're putting in non-wood supports there too. But I will say that can type supports that started with the Burrell can, a lot of other companies have them now that the patent expired on it or whatever it is, timed out. There's other companies that have basically the same thing. You can do very similar sort of results with cans. I mean, they're a very strong support too. They do accept a lot of deformation. They're used a lot, like I said, out in Utah and that sort of thing. But I think that was pretty good for the two changes. And then, of course, there was the discussion of advantages and disadvantages of those. Um, like I said, 9-point cribs, disadvantage, labor, right? Monitoring. Advantage is you get to know what's going on. The disadvantage is you have to install more things or have more people to do these things, right? So it's gonna cost money. It's not gonna be free, right? Uh, Training, sort of the same way. That it is going to cost you. So there are advantages and disadvantages to both these things. A lot of the disadvantages are financial in nature, but if this is necessary, then you're probably going to need to do it, right? Um, yeah. So with that, we'll move on to week 7, ACPS results. Like any model, only as good as the data you feed it. What field measurements like mining height, pillar dimensions, and geology are most important to verify after mining begins? So this is sort of like that geotechnical assessment question, right? And so basically, as far as pillar dimensions go, the geology part's not terribly important unless you are using the 50% rule and discounting a portion of the rock's height for your pillar design. And if you are, you do need to know that rock is indeed significantly stronger in coal and does contribute to increasing the strength of that pillar. Now, we haven't really learned how to do that yet, but we'll go over some techniques for that in the ground control class. How you can determine, what the strength of that rock might be. We're also going to bias a point load testing machine so we can play around with that a bit in looking at rock strength and that sort of thing. So that would be where the geology would tend to come in. Otherwise, as far as what the roof's composition is, that's important for support, but not really important for the input into ACPS, right? The most important things you're going to run into, okay, is going to be like the mining height and the pillar dimensions. If you got off on mining those pillars significantly, or you've got entry dimensions that are too wide, that needs to be double checked, to make sure that's still safe to mine. Also, the mining height. You see, it was designed based on an initial mining height that may or may not be what it is when you actually mine it. And so you need to come back in there and make sure that the mining height is what you think it is. And if it's not, then you're going to have to mitigate that somehow. And that's most likely going to be additional leaf blocks. Okay? How might real-world variations from the design affect pillar stability factors calculated in ACPS? Well, if the pillars are smaller than they were designed to be, the stability factor is going to go down. If they were initially, sized right at the 1.5, it may not meet the criteria, right? The mining height. When you increase that height, the pillar strength goes down, and so does the stability factor, right? So there are, um, you know, real world variations that need to be taken into account prior to retreat mining, and what steps can be taken to mitigate that. Once again, the biggest is going to be, narrowing that panel down, right? You're going to have to leave a little bit, another block or a half block or block and a half or 2 blocks, whatever it takes, to get that down to where it, mitigates that risk, gets you back up to an acceptable stability factor. All right. And so that leaves us with week 7. We're currently, it's still Saturday. It's like 6:40 p.m. I'm starting to get hungry, but um, yeah. So this is we're still on what, week 9. Okay. We're going to continue with sort of the pause on discussions and quizzes at least through next week, so I can get through more of the sort of walkthroughs for the projects, and then we'll go from there. Okay, so with that, I'm going to close it out. Once again, thank you so much for watching. Like and subscribe to the channel if you get the chance, and we'll see you next time.